This is Elegoo's first CoreXY 3D printer, the Centauri Carbon. First announced at Rapid TCT in June of 2024, it's finally seeing the light of day in mid-February 2025, and we're getting a look at it right after this. I'm Brian, and you are watching BV3D. Hello 3D printing friends and welcome back. Today we're getting a first look at the Centauri Carbon. We'll start with a quick rundown of the specs, then look at some prints, and finally I'll share my experience with it, both good and bad. Ready? Here we go. So here are the Centauri Carbon's specs and features. It's a CoreXY 3D printer with a 256 by 256 by 256 millimeter build volume, enclosed in an aluminum frame and wrapped in a steel and glass exterior. It's got a nice 4.3-inch color touchscreen, so you can control the printer and select files for printing. It's also Wi-Fi capable, so you can send print jobs to it from Elegoo's slicer. And if you don't want it to be online, you can save sliced files to a USB flash drive, plug that into the front of the printer, and print that way. It has an all-metal hot end with a direct drive extruder feeding 1.75 millimeter filament down to a 0.4 millimeter hardened steel nozzle that can get up to 320 degrees Celsius. The printer uses the nozzle as a bed probe, so it can automatically get a mesh of the bed, mapping out the high and low spots as well as automatically setting the Z offset. It has a single Z-axis motor driving 3 lead screws to raise and lower the bed. On the bed, there's a double-sided flex plate with a PLA-specific print surface on one side and a general purpose build surface on the other. And the bed's AC line-powered heater can get up to 110 degrees Celsius. Elegoo claims a maximum toolhead speed of 500 millimeters per second and a maximum acceleration of 20 meters per second squared. And the printer has quite a fan club. There's a big 50-20 blower on the toolhead for parts cooling, a big auxiliary parts cooling fan to improve cooling on high-speed prints, and an exhaust fan that pulls air through a filter to cut down on the smell of certain filaments when they print. Elegoo recommends using PLA, PETG, TPU, ABS, ASA, or PLA CF, but they also say you can print the carbon fiber versions of PETG, ABS, ASA, PET, and PA, that's nylon, along with regular versions of them as well. The printer has a built-in camera, so you can peek in on a print in progress and record time-lapse videos of prints. It has power loss recovery, so you can resume a print after a brief power outage. And of course, it has a filament runout sensor, so it can let you know when you need to run out and get more. The printer comes well packed, and even with a glass lid and a glass front door, it survived shipping without a problem. Unboxing it and getting the screen and spool holder attached and plugging in the power cable took me under 10 minutes. After that though, there's a first run self-test calibration to do. Your part of it is responding to a couple of prompts on the screen. Then the printer does its tests and calibrations unattended, but it does take about 30 minutes to complete. And you'll probably want to put the printer on Wi-Fi and update its firmware. Now, I don't know if Elegoo will have the firmware update available for flashing via USB or not, but that's it for the specs and features. Now let's take a look at a few prints from the Centauri Carbon. This is the first thing I printed on it, a pre-sliced benchy. I used some beige PLA for this, and it took about 15 minutes to print. There's a very minimal amount of stringing, so that's not bad. The surface finish looks decently okay. The first layer has a little bit too much squish. On the back of the wheelhouse roof, this corner had an issue, and it looks like the Z-seam was a bit rough. You can see the same effect on the corner of the stern. The top surfaces look fine, although there are a few tiny gaps in some corners. Keeping in mind that this benchy is tuned for speed instead of quality, the printer did a pretty good job with it. Next, I switched to some blue PLA and I sliced and printed this thing. It was originally designed for printers being crowdfunded on Kickstarter to give potential backers an idea of how that particular printer could handle tricky model geometry. So this example printed in about an hour and a half. You can see some wispy stringing in the spikes at the top. And you can see where the bridging failed at the outer edge of the top platform, along with some cooling related issues on that overhang for the corner. The short bridging tests at the bottom are okay-ish, but the medium and longer ones have some sagging. The clearance or tolerance test seemed to do pretty good in the 0.3, 0.4, and 0.5 sizes. I needed to push lightly on the 0.3s to get them out, but the cylinders for 0.4 and 0.5 had no issues. The 0.2 cylinder is a permanent part of this one though. Despite the wispy stringing on the spikes, I'm impressed that it printed all of them completely and without deformation. Underneath, the overhang tests actually look pretty good, even on the 20-degree and the 15-degree ones. Mostly what I see with this print is that the bridging speeds probably need to be adjusted in the slicer. Next, I switched to some Polymaker PETG and printed Aria the Dragon by Luby 3D. She printed in 2 hours and she turned out really great. There's no stringing and actually no issues that I can see at all. The overhangs printed fine, I don't see any ringing, and the surface finish is very consistent. I couldn't ask for a better result. Then on to some yellow ABS. This is a mini version of the Centauri Carbon, designed to attach to the back of the printer to catch the little purge poops. It printed in about 2 hours, 15 minutes. This turned out mostly okay. Despite printing with a brim, when I got it onto the turntable I could see that the corners lifted a little bit off the bed during printing. So a bed adhesion aid like Vision Miner's nanopolymer adhesive would probably help with that. The other main thing I see with this is little zits on the surface of the print from, I think, the random positioning of the Z-seam. Apart from that, it attaches perfectly to the back of the printer and does what it's supposed to do. This could also be a good model to print and keep on your desk to put pins and stuff in. I also sliced and printed my desktop trash can in spiral base mode and scaled it up to the maximum print height. It printed in 3 hours. This one didn't seem to have any issues with corners lifting, probably because it doesn't have any corners. I printed this one to see how the printer would do on a tall ABS print, and it seems to have done fine with it. One nice thing about this model at this size is that it works really well for using those plastic bags from the grocery store as trash bags. Okay, so that's about it for the prints. So after using the Centauri Carbon for a bit, here's what I like and don't like about it. The Centauri Carbon's load and unload feature works pretty well. Its tool head has a built-in filament cutter, so when you unload it, the printer cuts the filament right where it goes into the hot end and then retracts it a bit. Then you can pull it back out of the printer the rest of the way and load in a new spool. To load filament, hang the spool on the right side of the printer, feed the filament through that runout sensor and all the way up to the tool head. On the filament screen, it lets you set the nozzle temperature for loading. So when you press the load button, the printer doesn't complain that the nozzle isn't heated, it just heats it and then starts loading. Oh, and part of that loading process includes purging out the previous filament from the cut and unload sequence. You'll have to kind of watch the nozzle at the back of the printer to see if the new color is coming out. If it's not, there's a button on the screen to feed more. But something I don't like about it is that when it purges filament during the loading process, it doesn't reliably drop it down the poop chute at the back of the printer. Sometimes it gets constipated and it can take 2 or 3 presses of the try again button to create enough purged material to drop down the chute. The way the printer unloads and loads filament, cutting and retracting the old filament, feeding in new filament to purge out what's still in the nozzle, and squeezing the squiggles out the poop chute on the back, feels an awful lot like there's a multi-filament system in the works, so make of that what you will. Who knows? Maybe Elegoo will surprise us. I mean, everyone else is coming out with multi-filament systems, right? So let's talk about the flex plate. It's a pretty thin plate, so it's super easy to flex, and that makes it easy to remove the finished models. I've only used the general purpose side of it for all these prints, and I haven't used the PLA specific side. The general purpose side leaves a nice texture on the first layer of a print. And that general purpose side has worked well for PLA and PETG. I do think I need a bed adhesion aid for ABS though, just to make sure the corners stay down. Next, the enclosure. The enclosed design is good for higher temperature materials that need protection from drafts like ABS, and it keeps the noise level down as well. The aesthetics of the enclosure are also nice, with the dark gray color, tinted glass, and the white graphic elements. As with most fully enclosed printers, you should remove the lid or otherwise allow for ventilation for PLA prints, but doing this will increase the noise you'll hear during printing. Now, the internal lighting. Not gonna lie, it's pretty weak. And with the tinted glass, it's difficult to see what's going on inside the printer even when you're standing right in front of it. I think the printer needs brighter lighting. This would also help the camera's ability to see. I mean, it's nice that it has the camera and all, but to get a reasonably well-lit time-lapse, I have to shine a bright light through the printer's door. For the most part, I like the touchscreen user interface. It's similar to the one on Bamboo Lab and Creality printers. It's bright, sharp, and easy to read. That said, I would like to see slightly larger touch targets to accommodate my fatter fingers. And some parts of the user interface still need a bit of refinement. In some places, there's more text than will fit in the designated area of the screen, and you can't see what else it says. While the settings screen allows you to scroll through a list of settings as you would on a smartphone, the video list part of the camera screen doesn't. It has up and down arrows that overlap the export buttons. When a print job is finished, a message lets you know and tells you how long it took to print. There's a button to print the model again and a button to cancel, but you aren't canceling anything. The print is already done. This should be an OK button to acknowledge the printing completed message. Also, the calibration screen's buttons don't have super accurate descriptions. Like, input shaping doesn't reduce the appearance of layer lines on a print. Instead, it's intended to reduce ringing or ghosting artifacts. And bed leveling doesn't ensure the printer is getting correct print settings. Print settings are determined by the slicer. One thing I like about it though is that when you select a file to print, it shows you what kind of filament it was sliced for. Like here, this was sliced for ABS. The included Elegoo slicer, which is based on Orca slicer, which is based on Bamboo Studio, the internals of which are based on Prusa slicer, which is based on slicer with a 3 for an E. It works exactly like you'd expect if you're familiar with either Orca slicer or Bamboo Studio. With the printer on a Wi-Fi network and added to Elegoo Slicer with its network address, you can interact with the printer in the Slicer's Device tab. And really what it's showing you is the printer's web interface, which you can also access with a web browser. From the Device tab, you can control the printer's motion system, moving the toolhead and the bed around. You can also control the fans and the internal lighting. You can also see and set the nozzle and bed temperatures and see the temperature inside the enclosure. You can see a list of G-code files that have been uploaded to the printer's internal storage. You can start one of them printing, and you can see a history of things you've printed. You can also see a list of video files the printer has created, or you could if it would show them to you, but it doesn't. And you can monitor the onboard camera feed, sometimes. The camera streaming is unreliable. It works until it doesn't. Here's what it looks like when it works, and here's what it looks like when it doesn't. Sometimes turning the printer off and on again will fix it for a while. Another convenience of having the slicer configured to talk to the printer over the network is the ability to slice a file and then send it directly to the printer to start printing. And that worked a couple of times. Now it doesn't. I consistently get one of two errors when I try it. I either get a failure when receiving data error or a WebSocket handshake error. Turning the printer off and on again and quitting and relaunching Elegoo Slicer does not fix it. And for those of you who would say, well, that's what you get for using a Mac, I've experienced it on Windows as well. Weirdly, on those times that sending a print job to the printer did work, it turned off the printer's time-lapse feature, so I didn't get time-lapses on those prints. So based on my experience, I think the firmware needs some work. One interesting side effect of the errors I get when trying to send a job from the slicer to the printer is that the rest of the controls in the Device tab often stop working after that error pops up. To me, it seems like one or more of the software components running on the printer crash, and then the printer's web server can't communicate with them. So the Device tab can't show you the current file list, and things like fan and light control don't work. So I've had to go old school, slicing files and exporting the G-code to my computer. Then I put the printer's flash drive in my computer, copy the file to it, and then take the flash drive back over to the printer to start the print. And that works, but it's not as convenient as having the slicer and the printer working together like they're supposed to. Another firmware issue is that some of the graphics shown in the device tab are still in Chinese. Like the empty inbox graphic here in the video list section, that apparently says no data yet. And the characters after the Elegoo logo apparently mean love cool. So I guess that means Elegoo loves cool stuff. I love cool stuff too, so it looks like we're on the same page. Fortunately, unlike hardware, the printer's firmware is something that can be updated easily post-purchase. So in theory, the reliability of things like camera monitoring, uploading and printing from the slicer, and interacting with the printer's web interface will get better. I don't want to criticize without offering ways to improve the product, so here's what I'd like to see Elegoo address on the Centauri Carbon. Hardware-wise, the chamber lighting needs to be brighter. And they need to fix the firmware or the slicer, whichever needs it, so the slicer can send jobs to the printer over the network and start them printing without errors popping up. And fix it so the camera can be reliably monitored from the slicer's device tab or a web browser. Fix the issue where sending a job to the printer turns off the printer's time-lapse feature. Fix the no files yet graphic so they're displayed in the selected language. Fix the video list so it shows the printer's saved videos. Change the cancel button to an OK button on the your print is done message on the touchscreen. And finally, adjust the wording on the calibration buttons to better reflect what they do. So it's time to start wrapping up this first look at Elegoo's Centauri Carbon CoreXY 3D printer. The hardware seems great, the print speeds seem great, but the firmware needs a bit more attention. There's a link in the description if you want to check it out. Thanks again to Elegoo for sending this over free of charge so we could get a look at it. And big thanks to everyone who supports the channel, whether with channel memberships or by using the links in the description. If you liked this episode, give it a thumbs up and maybe subscribe so you don't miss new ones. Well, 3D printing friends, that's about all the time we have for this one. And now that we're at the end, let's go print something cool. When I got it onto the turntable, I could see that the corners lifted a bit.